For today's lesson, our focus standard comes from Grade 8 Expressions and Equations, Standard 2. Evaluate square roots of perfect squares and cube roots of perfect cubes. So our topic today, coming from Pythagorean theorem in the number system, is perfect squares and cubes. Our essential question is, how can we identify perfect square and cube numbers and their roots? Please take a moment, pausing the video if you need to copy down the standard, topic, and essential question into your header, along with today's date, set up your question column, and your note column, and resume the video when you're ready to begin. So for today's lesson, we're going to start out by just defining what the perfect square and a perfect cube are. So a perfect square is when a number is found by raising a whole number to the second power. A perfect cube is a number found by raising a whole number to the third power. So any whole number taken to the second power is a perfect square, and any whole number taken to the third power is referred to as a perfect cube. So let's just dive in here. I've set up a multiplication chart, and you're welcome to draw one in, but I know some of you have some of them in your math journal or you have them in your planner. And if you'd like to do some of the highlighting that we're going to see on this multiplication chart there, then that would be okay with me. So as we look at perfect square numbers and their square roots, and we think about a multiplication chart, which I know you've seen and used since elementary school, we can see why they would be called squares, and we can easily find their square roots. So if we look at the first perfect square, that would be 1, because 1 times 1, or 1 squared, equals 1. What's nice is you can actually see a square that has an area of 1 as well. If we take the next whole number 2, and we square it, multiplying it by itself, then we get 4. So 4 is the next perfect square, and on our multiplication chart we can see it takes up the space with an area of 4. We keep looking at this. 3 squared is 9, so 9 is a perfect square, and its square root is 3. 16 is a perfect square, because 4 squared is 16, so the square root of 16 is 4. So on and so forth. So these numbers here, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144 are the first 12 perfect squares. So really important that you start to memorize these. I know most of you have, but to think of them as perfect square numbers, and when asked what their square root is, what number multiplied by itself or squared equals that. So I'd like you to answer just a few questions here off to the side. And again, mentioning that all the highlighted numbers here in our multiplication chart down the diagonal are the perfect square numbers, the first 12. Let's go ahead and have you find the square roots of some of these. So here I'm asking for the square root of 1, the square root of 4, the square root of 9, the square root of 16, on down to the square root of 64. Please go ahead, pausing the video if you need to copy this down into your math journal, into your notes, along with the answer. And then resume the video when you're ready to check your work with mine. So it should look something like this. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, and lastly, the square root of 64 is 8. I could have also asked questions like, what is the square root of 121? And the answer would be 11. Now let's take a moment to talk about perfect cubes. So here I've just started with the first 4. perfect cubes, and I've drawn it out because it is actually found, as mentioned in our definitions above, taking a whole number and raising it to the third power. So 1 times 1 times 1 is 1. So the first perfect cube number is 1. Then we could ask a few more questions. We see that that is because, as I mentioned, in our three-dimensional image here, 1 times 1 times 1 is 1, or 1 to the third power equals 1. So what is the cubed root? Notice we're still using a radical sign, but now we have an index of 3. So what is the cubed root of 1? Well, because it is 1 to the third power, that equals 1. The cubed root is 1. Let's take a look at the next perfect cube. If we take the next whole number 2, and we take 2 times 2 times 2, what do we get? If you said 8, I would agree with you. So 8 is the next perfect cube number. And as we just saw, that is because 2 to the third power equals 8. So what is the cubed root of 8? The answer would be 2. See if you can follow the same pattern as I've set up here for the first 2 perfect cube numbers and find the next 2. And fill in your chart here. Pause the video to do that, and then resume the video to check your work with mine. Alright, so let's take a look at the third perfect cube. 3 times 3 gives us 9, times 3 gives us 27. So the third perfect cube is 27. That's a result from taking 3 and raising it to the third power to equal 27. So the cubed root of 27 is 3. Lastly, if we take 4, to find the fourth perfect cube number, 4 times 4 is 16, times 4 is 64. So 64 is the fourth perfect cube. It's found by taking 4 and raising it to the third power. So the cubed root of 64, is 4. So for 8th grade math standards, they are asking that we memorize and easily evaluate the first square roots and their perfect squares, and the first cubed roots and their perfect cubes. So these are numbers that you will want to be familiar with to be able to quickly find square roots and cubed roots of numbers. Please make sure that your notes are complete, and we will continue to work with these numbers in class.